for the others, maybe we can just start with the introduction, because that will be quite short. Knowing that everybody here knows everyone else, especially the speaker. So our speaker, this is the graduate seminar series. We conduct this to give opportunity for our graduate scholars to share the salient results of the research that they conducted in connection with their graduate study program. So for this semester, we have our first speaker, or first presenter. She's from Myanmar. I think she needs no further introduction from everyone present here. Because she's the past SSA president. So, and she's also she is a assistant supervisor or deputy officer, right? Now deputy officer under the Myanmar Agricultural Services of Myanmar Agricultural Service, right? And with masters in MS Entomology at the same Agricultural University and diploma and BS Agriculture also at the same university. So ladies and gentlemen, without further ado, Dr. Myint Myint Soe.
Good afternoon, everyone. May I present the results of my research, and the title of my research is Superparasitism and Multiparasitism of 3 Mango Leafhopper species by Strepsipterans. Here is 2 Strepsipterans, Halictophagus fulmeki under the family Halictophagidae, and Callipharixenos philippines under the family Callipharixenidae. May I introduce about mango predation and the effect of mango leafhoppers. Mango predation is affected by various biotic factors. Among the biotic factors, mango leafhoppers are the most serious pest. In the Philippines, there are 3 species of mango leafhoppers, namely Hydroscopus libialix, Hydroscopus niveosparsus, and Bacteria nigrobilineator. Among them, libialis is considered a major pest because of direct injury to the flowers. Many natural enemies attack on mango leafhoppers, including Strepsipterans. In the Philippines, recently identified 2 species of Strepsipterans are Halictophagus and C. philippines. The scientist is from the UK, and she identified these both species in 2012. So, Strepsipterans perform not only monoparasitism but also super and multiparasitism on the mango leafhoppers. The objective of this study is to determine the rate of parasitization, to characterize the type of extrusions of parasitoids, and to describe the different stages of parasitoids, and to determine the effects of superparasitism and multiparasitism on the primary and secondary reproductive organs of 3 species of MLH. Here we conducted 3 studies. The first study is about parasitization of mango leafhoppers by both Strepsipteran species. The specific objective is to determine parasitization. We will identify here type and rate, so that will be the duration for 1 year period on the 3 species of mango leafhoppers, and the last objective is to examine the relationship of the factors among population density of hoppers, weather factors, and parasitization rate. So here we will use for the statistical analysis for the correlation factor, Spears-Mann-Rand correlation analysis was performed. We conducted 2 times our survey in the first study. So firstly, 60 mango trees around the Shubi campus were surveyed weekly to collect mango leafhoppers. That is in February. That is 1 month only. So for the collection of mango leafhoppers, we will choose each tree and then divide it for sessions. For one section will be 25 sweeps, and a total of sweeping is 100 sweeps per tree. So, and then the Callipharixenos from the insect nest will be transferred to the plastic bag and will be brought immediately to the laboratory for further examination. So, before this examination, we have to be immobilize the insects in the freezer at 0 degrees Celsius for 8 minutes. And then we will be identifying the sex and the species of hoppers and the parasitoids, and we will assess the parasitization. So here the characteristics of parasitization is very clear because the parasitoid extruded from the abdomen of the host. The female parasitoid will extrude from the ventral side of the host, and the male parasitoid will extrude from the dorsal side of the host. So that is very prominent factor for the characteristic of parasitization. So we will source the weather data of around the campus from the acrometeorological station of UPLB, and also recorded the phenology of plant condition, flowering, leaf flash, and mature leaf with timely. So, based on the results of preliminary survey, 33 mango trees were selected. How much parasitization rate on the tree and the phenological characters, such as the dense canopy structure of the mango trees and the height of the mango tree, something like that. So based on these factors, we consider and we selected 33 mango trees. So the sampling procedure for the final survey is the same as the preliminary survey. So here I mentioned what is the characteristic of parasitization. So the most prominent factors of parasitization is external extrusion from the ventral and dorsal of the host. For the parasitization rate was computed by using the following formula. So number of parasiticide hosts that was divided by total number of mLh collected. The meaning of total is the combination of parasiticides and parasiticides hoppers together, and then the result was multiplied by 100. That is the parasitization rate. So the result is, based on this initial and final survey, there was no parasitization in the first week of February. However, that second and fourth week of February, only monoparasitism on the Callipharixenos and multiparasitism on Nereus parasite was observed. And the population of female hopper is extremely higher than male population, and the female parasitoid is also higher than male parasitoid population. Here is the total collected number of normal parasiticide, normal and parasiticide hoppers with different species: Callipharixenos, Nereus parasite, and Bagheera. May Halictophagus species attack on 3 species of Mango Leafhoppers. However, female parasitoid of Halictophagus species attack only on Callipharixenos, and also female cephalopods attack on Nereus parasite only. So the species preference of male and female is very different in Strepsipterans. Superparasitism by Halictophagus was observed on both Callipharixenos and Nereus parasite. However, only multiparasitism on Nereus parasite by the combination of 2 parasitoid species, and only male fulmeki attack on Bagheera nigrobiliniana. So the host preference on the species of hopper is very different. For the Callipharixenos, we observed 2 times our peak population in March and May. That is concerned with the flowering of mango tree and the weather factor also. The relationship will be explained in next chapter very detailed. So the lowest population density was observed in January, and however, the highest monoparasitization percent in January was observed. The the highest superparasitization was observed in March. That is the kind of relationship between hopper density and the highest superparasitization rate. So the meaning is, we can call it that most of the superparasiticide hosts are at the time of higher densities of hoppers. Here also, female population of parasitoid is always higher than male population, and parasiticide, female hopper species, hopper population was higher than male population. However, based on the sex discrimination, the parasitoid mostly prefer on male. That's why this study, most of the male parasiticide hopper was collected than the female hopper. So the species preference, host species preference by the Strepsiptera is also different. For the Niveosparsus, the peak population time is in April and May. So the lowest population density of hopper and the highest parasitization rate. So will not be concerned much. However, superparasitization rate was depend on the peak population density of hopper. So more parasiticide, more superparasiticide hopper can be collected at the population times, peak population times or hopper. Male population, fulmeki, is higher than female sea Philippines. So the species preference, so if we will compare both parasitoid species preference, so Niveosparsus, male fulmeki is more preferred on the Niveosparsus than female sea Philippines. So normal and parasiticide female hoppers and parasiticide female hoppers populations are always higher than male population. So here, the species preference of parasitoid is mainly depend on female. That is the reverse result because male hopper was more preferred by parasitoid in Callipharixenos. However, female hopper was more preferred in Niveosparsus. For the Bacteria nigropoliniator, the highest population was totally different with Callipharixenos and Niveosparsus. Here, the peak population time is the beginning of the year, and here, the peak population time of Bacteria is mostly at the end of the year, so December, and the beginning of next year, again, the January, so like that. Their peak population time is totally different. And also, the lowest population density and highest parasitization rate, it does not, both of these factors did not connect each other. So the lowest population can support the highest parasitization rate, so not connection much each other. And parasiticide female population was higher than male population. However, parasitization on male population is higher than female. Based on these results, it can be concluded that among the three species of hopper, the parasitoid mostly prefer on the Callipharixenos. However, mostly the population of Callipharixenos and Niveosparsus is always higher than Bacteria. So both of the Idioscopus species prefer on the flower of the mango. That's why both of these species was observed in the flowering times of mango tree. However, Bacteria mostly prefer on the leaf. That's why their peak population time is December, January. So at the time, the tree have only the mature leaf and a few sporadic leaf flush and sporadic flowering only. So not peak population, not peak flowering time of the mango tree. Temperature also positively influenced in the population density of Callipharixenos and Niveosparsus. That's why the increasing rate of both parasitoid species always connect each other. However, the Bacteria is almost reversed with Niveosparsus and Callipharixenos. So environmental factors did not influence on the Bacteria. For the study 2, We characterize the types of extrusion from both parasitoid species or how much will be different between each other. So we study them. Here is the male parasitoids. Based on this character, we can assess what is the parasitization of Strepsiptera. This is the male extrusion, and this is called Cephalotica, and the plural is Cephalotica, and the symbol is CTA. So that is male parasitoid extruded from the dorsal side of the host. And that is the female parasitoid and extruded from the ventral side of the host. So the terms for the parasitization, when Strepsipteran parasitoid per host, it's called monoparasitism. It will be the same species, but more than one Strepsipteran parasitoid per host extends Superparasitism, and the mixed species together, more than two Strepsipteran parasitoids per host, is called multiparasitism. The objective of the second study is to differentiate and characterize the extrusion of both parasitoid species and their to determine the morphology and behavior of their immature stages of parasitoids based on the three species of hopper. So its collection method was the same as the study one, however for the dissection. So we have to choose how much sample we will dissect for that study. So 10 each normal and monoparasiticide hopper, both male and females, were dissected weekly. And however, both of the superparasiticide and multiparasiticide hopper was dissected all weekly because the population of our collected superparasiticide and multiparasiticide specimens are very few. That's why we have to dissect all of the collected hoppers. However, normal and monoparasiticide hoppers the population are too high in our collection. That's why we have to sample them. How much is enough sample size for our dissection? Here is the how much hopper dissected weekly for the 39 weeks collection. So here is for the Lepianic. So this is the total amount dissected for the Nebius parasite. To characterize and describe the types or extrusion of both parasitoid species, so we have to get the specimen. We have to get the specimen first. So choose the specimen preserved in the ethyl alcohol, and individually the specimen was put on the glass slide, and firstly we have to get the wings and the legs so to get the better view for taking picture. So and then the specimen the specimen was put on the glass slide ventral side up, so to take the picture for female parasitoids, and for the dorsal side, take the picture is the protrusion of male parasitoids. And then the dorsal side of the host was kept by dissecting needle and remove the reproductive organ and together with the parasitoid. So, and then take picture again. That's why I mentioned we have to take picture twice before and after dissection. So for the measurement of the length, the body, something like the different body parts, so we have to use the software ImageJ. That's why we have to take picture. And also location, position, and status, developmental stages of extrusion are also recorded. So for the second experiment, larviposition and adult emergence. What is the meaning of larviposition? So the female parasitoid will produce their offspring. That is larviposition. Adult emergence is the male, fully grown male adult, so that will emerge from the Cephalotica. That is called adult male emergence. So the dissection of the specimen is the same, the procedure as in experiment A. Here, some stay-alive specimens should be kept in the glass vials. So we have to put the stay-alive parasiticide hoppers in the glass vials, and we have to provide the fresh mango leaves and flowers, and then the glass vial was loosely covered with the cotton wool. And then we have to check 25 minutes intervals for that specimen for 24 hours to observe the larvae position for the adult emergence also. So at that experiment, we have to record duration of larvae position time interval for emergence and morphology and behavior, and also different parts of the first instar and different body parts of the male parasitoid have also take picture and then measure in image G again. For the experiment C, X and triangulin. So from the female parasitoid, inside the oviduct will contain the X and the first insert triangulin. So to study how number of eggs per oviduct, so we put the exact parasitoid on the class slide and then with a drop of 70% ethyl alcohol and use the dissecting needle to pull apart the oviducts. And then the unnecessary fragments of the oviducts was cleaned out. And then so you will see clearly the number of eggs are whitish and globular eggs on the glass slide, and then you can count under the microscope. So after that take picture, so to confirm your counting number of eggs, so you have to recount again in the images. So 2 times you have to count to confirm your counted number of eggs. So for the experiment D, so that is also connected with experiment A and B. The presence of the immature parasitoids, I will show many very good picture like that. The presence of the parasitoids, so immature form. There are many different immature forms. There is soft body, creamy white larvae, triangulin-like larvae. So the triangulin is look like shrimp. So golden color small shrimp. So that is their appearance. And the other form is hard and dark larvae. The color is black, but their appearance is very hard. So all of these numbers, we have to count and measure, photograph, and some specimens should be mounted temporarily on the glass slide, but some specimens should be stored, should be preserved in 70% ethyl alcohol or 80% ethyl alcohol. So for the measuring of oviducts, we have to measure from the tip of the abdomen to the end of the first segment to the last segment. So here we don't need to think about the extruded cephalothorax because the cephalothorax is the middle of the oviduct. So we don't need to consider to measure the cephalothorax. Just only measure the tip and end of the oviduct. So the result is from the parasiticide hoppers, there are no more soft-bodied hard larvae. So nothing. So they are very healthy. No immature forms are observed in the abdomen of the hoppers. So measurement re-extrusion can observe in Lipialis for extrusion in Smidios parasites. So 3 parasitoids is enough the space and nutrient availability from the host. So maximum 3 is suitable for 1 host 3 parasitoids. For the Niveus parasite, 1 host can support 4 parasitoids. So if the female parasitoid, both female parasitoid extruded together from the host, so they will choose the common position is segments 3 to 4. And for the male, will choose segments 3 to 4. However, male will protrude from the targite dorsal, and the female will protrude from the sternized ventral. So more than 2 parasitoid per host, the extruded position will totally change. It will not be the same position, so very apparent position you can see. After Superparasitism cannot decrease the size of the extrusion. The extrusion size is very normal. It doesn't concern with the degrees of parasitization. So here you can see many pictures. We identified the phasex, the different stage phasex of the male pupa. That is only the stage is the same. Male pupa stage is the same, only one stage. However, the pupa pass through many phases. this is the first stage, newly developed pupa. Here is the exact parasitoid. So this is the male. So very newly developed stage. At the stage, inside the male pupa is still intact with the puparium. So under the microscope, you will notice clearly that pupa inside the under the puparium. Here, this is the second developmental phase. So completely developed. At the time, the male pupa, the appearance will be whitish, and you can see the black-colored pigmented compound lines here. So another stage is about to emerge, pupa stage. So the subplotica is here a little bit whitish. Here is already turned black. And the parasitoid, male parasitoid also already changed color from whitish to black. So that is the final stage of puparium. That is the final stage of male pupa. Here is only left the male puparium, and the adult may already emerge from the subflotorus. At the time, there is very good condition for the infection of microorganisms, fungus or bacteria. So, and also it could be the good condition for the desiccation of internal visceral organs. So the hopper will die soon. That is the different stages of female parasitoid. So ankle, that is the subflotorus, and here the whitish region is the ovisex. So two types you can see. This is the virgin female. Virgin female, not that is the subflotorus not yet extruded outside, that is still inside the abdomen of the hopper. The abdominal wall is very compact and very tight, so inside is just only the jelly-like substances. So no eggs, no triangulin. And then they fertilize with male parasitoid and it will change like that. So the ovisex filled with whitish and globular eggs. So that is the flotorus and that is ovisex. And then the eggs will mature and transform into triangulin fat insert. So the color of the ovisex will change like that. This is the golden color here. This region is the show the development of triangulin. So the triangulins are golden color. So the egg is whitish, but the triangulin is golden color. So the maturation of triangulin is not the same. So not synchronize each other. They will develop batch by batch. So this batch will mature first, and then the whitish eggs will transform into triangulin again. So they will release from mother subflotorus batch by batch. So later the ovisex will begin like that. So nothing inside, but the wall of the ovisex is already loosened. So here is the different Strepsipteran, female Strepsipteran. I study here some female fulmeki and female sea philippines. So the subflotorus is short and round. Here long, and the color is also deep brown. Here is just pale yellow. So I studied these two Strepsipteran. In my study, I also found the new two Strepsipteran species in the Philippines. That is not that identified species, so that is very newly found result. From the host is from Bacteria, that is the host is from Callipharixenos. However, this parasitoid species was classified under the genus Halictophagus based on their morphological appearance and inside the genital ducts of ovisex. So both possess 3 genital ducts each. So I make the larvae position. What is the larvae position? Here, the golden color triangulin emerges from the mother subflotorus. The host is Callipharix, and that is the triangulin from the Callipharix, and the female parasitoid is Halictophagus fulmeki. That is the host X niveus parsu, and here is the female parasitoid extrusion. You can see around here the triangulin. So that is the meaning, that is the larvae position. Emergence of triangulin from mother subflotorus. This is the emergence of adult male. So from male subflotica, the male will emerge like that. So this is the batch of triangulin. So this is the batch of eggs. So the eggs will transform into the triangulin. Pale yellow shiny. So this is the triangulin from fulmeki. This is the triangulin from sea philippines. So just only noticeable point of view for both species is in color. Shiny but pale yellow. Here is golden yellow. So very bright color. But the morphological appearance, the number of segments, something like that, are mostly the same. This is the developmental stages. From the egg to begin the triangulates. Firstly, you will see the initial developmental stage of the egg cells. Only inside is the whitish color embryo. So just only egg yolks, not transformed to embryo. Here, it's already changed. So whitish and C-shaped triangulate already inside, and then the development will change to golden colored triangulate. And then the triangulate, the embryo will change to the C-shape and tubular triangle. That is the final stage development for the first instant. And then the triangulate will emerge from mother subflotorus and will attack another host. So that is the first, after they emerge from mother and their first infection stage to another host. So this triangulate was observed in the fat bodies of the hopper. This is already dead hopper because of the immunological defense of the host. So parasitization most of the time cannot be success because the hoppers can defend their enemy. So if the triangulate have the subcell parasitization, they can transform into whitish and soft creamy white larvae. This is the subcell parasitization characteristic for the Strepsipterans. It can be concluded that the same extrusion position from the female parasitoid. However, both of these female parasitoid species host preference is very different. So number of eggs per ovisex is mostly the same. However, the age and size, based on the age and size of the subflotorus, the egg numbers will be different. And the size of the host is just only depend on the maturity and age of the eggs. So for the computation of the nutrients, computation of the space, so the maternal body size of the parasitoid will decrease, and also the egg number will also decrease. For the study 3, the effect of superparasitism and multiparasitism was studied on the male and female reproductive organs of the 3 species. So, female and female reproductive organ, we emphasize only the secondary and primary reproductive organ, or the some parts, just only seminal-vesicles, only ovary like that. The objective is how much they will differ by different types of parasitization. So, the ovary will be smaller or will be bigger. The seminal vesicle will be reduced in size or will be increased in size, something like that. So, that is our objective. And also, the reproductive activity of the hoppers throughout the year. So, because of the parasitization, they can be reproduced eggs or not. So, the normal hopper will produce the eggs year-round. However, the parasiticide hopper will not be produce their offspring. So, because of the parasitization, the hopper will not build up their population anymore. As you can see, many hopper, but the parasiticide hopper will not produce their offspring anymore. So here is the total number of the hoppers for the Callipharixenos and for the Parasitoids. And also that is for the back error. Based on this dissection, we measure the ADA-goes, the ovipositor and secondary reproductive organ, seminal vesicle, common ejaculatory dead, ovary, and common ovidead as the primary reproductive organ. The result is increasing degrees of parasitization, so will be decreased in order for the length of ADA gas, and also increasing decrease of superparasitization by male parasitoids, so will be increasing the length of the male ADA gas. Here is the result is not the same. Because of female parasitoid will increase in length of ADA gas. Because of the male parasitoid, the ADA length will be increased. That could be, it can be because of the hormonal changes of the parasitoid. The female and male produce different hormones. That can be effect on the hoppers. However, no effect of ovipositor. So the effect of parasitization is more severe on the primary reproductive organ, not much severe on the secondary reproductive organ. Comparing seminal vesicle and common ejaculatory duct, seminal vesicle will be more affected by parasitization because the parasitoid directly press on the internal organ of the host, but for the common ejaculatory duct situated the narrowest part of the hoppers, that's why they cannot directly press on the common ejaculatory duct. They can press directly on the seminal vesicle and ovary only. So these parts are very important for their reproduction. Seminal vesicle is reduced in size, so that cannot be stored enough sperm for their reproduction, and ovary also. If the ovary is very decreased in size and cannot develop very well, so they could not produce the egg, and the hopper population will be decreased. So this is the male reproductive organ of and parasitized hopper. Well-developed seminal vesicle here. Well-developed seminal vesicle and well-developed common ejaculatory duct. Here is the reduced size of seminal vesicle and deformed common ejaculatory duct. That is tested. I didn't study about the tested in my research. Here is the well-developed female reproductive organs of and parasitized hopper. Here is the ovary of when male parasitized hoppers. Here is one female parasitized hopper, 2 female and 3 female. So the length of the lateral oviduct will be increased because of parasitization, and the size of the ovary will decrease. Here just a little bit the initial vitellogenic stage, but the egg will not develop. The development of egg will not be continued. Parasitization by fulmeki and Callipharixenos on the Nebius parasite. So here also, the effect on the secondary reproductive organ is not very serious. However, the reducing size of seminal vesicle and common ejaculatory duct is very clear. They will reduce size extremely. And also, ovary and mesh of common oviduct will decrease in size extremely by multiparasitization. Different parasitoid will be combined together per host, so they can be compete in everything. So their hormonal changes, also their competition in space, nutrients, and also parasitization on the hoppers. So the hopper will be heavy because they have to carry the parasite as overload. So they cannot be moved very well, so their mobility also will decrease. Here is the male reproductive organ of the Nebius parasite, another hopper species. So seminal vesicle and common ejaculatory duct, that is the effect of male parasitoid on the male reproductive organ. That is the effect of female parasitoid on the male reproductive organ. So the seminal vesicle, the seminal vesicle and common ejaculatory ducts are not very normal. So sometimes are very big, increase in size, or mostly very decrease in size. So abnormal condition is because of parasitization. Here is the reproductive organs of female hopper, non-Nebius parasite. Normal parasitous parasitized host. That is normal hopper. The ovary of normal hopper, so not that mature stage, not that reproductively mature stage. That is already reproductively mature stage with our developed eggs are inside. That's why the ovary is very big. Here is the ovary was attacked by the female parasitoid. Here the ovary is attacked by male parasitoid, so cannot develop anymore and decrease in size. If the hopper can produce the egg is already abnormal because of parasitization, deformed, shrinkage, and change in color. Parasitization by bacteria. Parasitization by fulmeki on bacteria. So here's only Secondary reproductive organ was not much affected by parasitization. However, seminophysical internal reproductive organ are mostly affected by parasitization because the parasitoid need to survive inside the abdomen of the host. So that is very near and directly breaks on the digestive system, reproductive system, something like that. This is also the reproductive organ of Bacteria nigrobilidae. The different species possess different types of reproductive organ. That is the reproductive organ of Bacteria. So here is the testis, here is the seminal vesicle, and here is the common ejaculatory duct. So the system is well developed. Here is the system is already registered. Both pictures are almost same scale. So this is the male parasitoid. This is the female reproductive organ of an parasiticide hopper. This is the female reproductive organ of parasiticide hopper. So that is male parasitoid. So the ovary cannot develop and one egg only develop. But the egg is already shrinkage, and so it will be normal and could not be produced offspring again. The effect of parasitization by fulmeki on the primary reproductive organ of the Lepialis is the most serious among 3 species of hopper. So secondary reproductive organ is not much very important. However, the internal reproductive organ are very important for the production of and build-up of their hopper. So my parasitoid has good potential as a natural control agent centered the mango ecosystem. The effect of parasitization by fulmeki on Clypeal is more severe than Nebulosparasu and Bacteria. However, C. Philippines parasitization is not much affected on the reproductive organ of the Nebulosparasu. Some abnormal eggs can develop in the ovary of Nebulosparasu and Bacteria, but they are already abnormal. So we don't need to worry about reproduction of new offspring of hopper because the parasite is already destroyed the reproductive system of the hopper. Temperature. Among the environmental factors, temperature mainly influence on hopper population because Clypealix and Nebulosparasu mostly prefer on flowers. So, good temperature and favorable rainfall condition will promote flowering of mango tree. That is enough food source for hopper population. So, the food source will support very high rate increase of the hopper population. However, the environmental factor and the food sources will not affect on the Bacteria nigrobilidae because this hopper species mostly prefer on the mature leaf only. If they can available the flowers, but mostly they prefer and they survive only on the mature leaf. Superparasitization, multiparasitization of female parasitoid has the relationship with temperature and density of hopper. That's why we can call it that more parasiticide hopper. More multi and superparasiticide hoppers at high temperature and at high population density of hopper for both species of Nebulosparasu and Clypealis. Because of the parasitization will not be the basic developmental stages of the parasitoid. So the newly developed pupar to the antepuberium. So the growth stages is the same for the female also. From the virgin stage to the final oocyte stage, there are no more changes in stages because of the parasitization. That's why I mean the basic developmental stages is the same. However, it can be extended a little bit their developmental time only, no stage. Nomadic development from semoparasiticide Nebulosparasu and Bacteria was observed, but the number of egg production is already decreased. When hopper can produce 200 to 3 normal eggs, however, the parasiticide hopper will produce only 1 or 2 eggs only. So from 200 to 300, the egg number will decrease to 1 or 2 only. The effect of parasitization on Flipialis is the most serious. That's why no ovarian development was observed throughout the study. The population of female parasitoids or female hoppers are then higher than male throughout the study. So high population of hoppers, if the density of hopper population will be very high, so more parasitized hopper will be collected. However, based on our formula to compute the parasitization rate, the hopper parasitization will be decreased. Because of the denominator, if the denominator is very high, the result will be small. Parasitization and multiparasitization under the natural condition is lower than monoparasitization rate. So, two recently found Strepsipterans was classified under the Halictophagus species. That is the good result of the year-round observation. Is just only 2 Strepsipteran parasitoids are new species in the Philippines. So I would like to recommend that. So the other students, the next students, want to study like that. So you should choose the mango varieties with not too high. The height should not be too high for the collection of hoppers, and also you should choose the dense canopy structure of the mango tree, and the mango tree should be full long and should be good fruit setting. And also, if you want to study the larvae position and as a biological control agent, you can rear the triangulin from the larvae position on the laboratory rearing, so you can find how will they infect the new host. So that would be the basic requirements for the biological control. For the next study, should check the width of the lateral ovided, the length and width of the lateral ovided, and also the width of the common ovided, because here I didn't study these parameters. However, the effect on these parameters are also very prominent and very clear. So that is my recommendation for the next study. So thank you so much for your kind attention.
Open forum. If you have any questions for our speaker. I have a general question.
Yes, ma'am.
Going beyond the study, what do you think are the implications of the findings of your study to the mango industry?
Because then these parasitoids are, Amanda is for an entomologist. These parasitoid species are very difficult to understand. But that is very good, and their performance and the natural condition is very good. Their parasitization rate, their production of the offspring could not be affected by weather conditions. And it also not depend on the hopper density, something like that. So they can maintain their big population density and other natural condition without the effect of environment and human action. So we can end by understanding the description, by understanding of their nature, their behavior will support effective management for the I'm really excited.
Any other questions? Comments? Violent reactions from the mangling and dissecting of the insects. So if you don't have any more questions, maybe please call on Dr. Bessie Burgos again to award the certificate of achievement.
go back to Yesi,
Yes,
to the Ministry of Agriculture. Congratulations and give our regards to everyone from Myint